morning, one and all. We can discuss today quantum theory. In that quantum theory, origin of quantum mechanics. Now, quantum mechanics is developed in the year 19th century because some difficulties are arised due to application of some ideas to the macroscopic bodies, because the Newtonian mechanics which we have observed for stars or for the planets at that time, this classical mechanics holds good. But when we observe some microscopic particles like atoms, electrons or protons, then serious difficulties is arised, and due to that here the classical mechanics fails to explain some ideas, and due to that there must be generation of new mechanics which is known as quantum mechanics. Here the quantum mechanics, when we study at that time, the origin of quantum theory, in that here black body radiation. What is meant by black body? Black body is nothing but the body which absorbs all types of radiation which will be incident upon it. Whatever the radiation which will be incident on the black body, that will be absorbed by that body which is known as black body. Now, how the black body is formed? Black body is formed by using a double wall cylinder here, and one side there must be the opening, and exactly opposite to the opening there must be a conical shape, and the inner side of this cylinder is coated with lamp black. Due to that lamp black, when the light is incident inside this body, at that time there must be number of multiple reflections take place, and certain reflections, the all light it will be absorbed. Okay, now when such a body is heated, at that time it will emits some radiations, and that radiations are studied by a simple graph, on which here on this graph here we take temperature as a parameter, then the nature of the graph is like this. Say this is the temperature T1, T2, T3 and T4, whereas T1 is less than, T2 is less than, T3 is less than T4. Now from this graph we conclude that the first conclusion is that the corresponding at a given temperature, say T1, the energy is not uniformly distributed. The distribution of energy is not uniform. This is the first point. Means as we observing these four temperatures, in that case the energy is not uniform. The second one is, we can say that at a given temperature the intensity of radiation increases with increasing wavelength. As we go the corresponding from lower wavelength side to higher wavelength side, the corresponding intensity it will be increases with increasing wavelength. As intensity increases, the correspondingly as wavelength increases. This is the second one. And the third one is that the corresponding as temperature increases, then lambda max temperature increases, the correspondingly lambda max is nothing but the wavelength at which the peak is observed. That wavelength is known as lambda max, and this lambda max it will be decreases is nothing but towards the lower wavelength side. The fourth one is that the corresponding wavelength is increased in the temperature causes the increase in the energy emission. Means as lambda max decreases, but as temperature increases, the correspondingly intensity of the emitted radiation also increases. And the fifth one is nothing but the corresponding whatever the area under the curve, it will gives the total energy of the emitted radiations. Now on these 5 points, there must be a MCQs which will be asked in the examination. Only you have to observe this graph, and from this graph here we have to note down these 5 points. But we can say that from these 5 points, represents the graphical representation of the emission of energy from the black body with the correspondingly wavelength by taking temperature as a parameter, and this is nothing but the corresponding black body radiations. Now here, as the first point is that energy is not uniform. Energy is not uniform is nothing but you see towards the lower wavelength side or towards the higher wavelength side, at a particular wavelength the correspondingly energy is intensity is maximum. Now as we move from lower temperature to higher temperature, the correspondingly lambda max it will be decreases. This will represent the discontinuous line. It will be shifted towards the lower wavelength side. As the corresponding temperature, the correspondingly intensity increases with increasing the lambda max. Intensity increases, the correspondingly peak of the lambda max. That means the correspondingly lambda max also increases. And the last one is, as we say that whatever the total energy for the particular temperature is there, to that particular temperature, the correspondingly total energy is nothing but whatever the area which will become under that particular curve, it will use the total energy of the radiation.
जवाहर कला विज्ञान व वाणिज्य महाविद्यालयातील सर्व विद्यार्थी बंधू भगिनींना विनंती की कोरोनाच्या पार्श्वभूमीवर आपले अध्ययन ऑनलाईन पद्धतीनं सुरू होत आहे, तेव्हा या ऑनलाईन पद्धतीच्या अध्ययनामध्ये आपल्या प्राध्यापकांनी आपल्या विषयाच्या व्याख्यानाचे व्हिडिओ करून ते ई गुरुजी या चॅनलवरती अपलोड करीत आहेत. तर तेव्हा सर्व विद्यार्थ्यांनी ई गुरुजी चॅनलला सबस्क्राईब करा आणि लाईक करा.